Hello everyone, welcome back to our data science playlist. Up till now, we have learned almost about the previous chapters. Now we are moving to our next chapters, which is logistic regression modeling. So, here we will learn how to perform logistic regression and how to perform Poisson regression. So, let's see that what is logistic regression? So, logistic regression is a powerful statistical technique that allows us to analyze the relationship between variables and predict the probability of a binary outcome. So, core concept, what is the core concept of logistic regression? So, logistic regression utilizes a sigmoid function to model the probability of a binary outcome based on a set of independent variables. This function maps a linear combination of predictors to a probability between 0 and 1. Then, what is the key advantages of logistic regression? It is relatively easy to implement and interpret it, making it popular in various fields. It is robust and can handle both continuous and categorical variables. It provides insights into the relationship between the predictors and the outcome. Now, what are assumptions and limitations? So, first, linearity assumes a linear relationship between the independent variables and the log odds of the outcome. It may require transformation or feature engineering for non-linear relationship. Next, we have second, independence of observations. It assumes that observations are independent of each other. Correlation between observations can affect the accuracy of the model. Next, we have third, multicollinearity. So, high correlation between independent variables can lead to unstable estimates and hinder model interpretability. It may require feature selection or regularization techniques. Next, we have interpreting logistic regression coefficients. So, coefficient interpretations. Coefficient indicate the change in log odds of the outcome for a 1 unit increase in the corresponding independent variable holding other variables constant. Odds ratio interpretation. The odds ratio coefficient represents the multiplicative change in the odds of the outcome for a 1 unit increases in the predictor. It is easier to interpret than coefficients. Next, we have model evaluation metrics. So, first, accuracy, the proportion of correctly classified observations. Second, we have precision, the proportion of correctly predictive positive cases. Then we have recall, the proportion of correctly predictive positive cases. Then we have Evans score, the harmonic mean of precision and recall. Basically, model evaluation matrix, we have also learned this model evaluation matrix with the same accuracy, precision, recall and Evans score in our previous video. So hopefully I don't need to brief this again. Then feature engineering and selection. First, feature engineering, transforming existing features into new ones that capture more meaningful information, improving model performance. Then feature selection, selecting the most relevant features from a pool of candidates, reducing model complexity and improving interpretability. Then third we have regularization techniques. So L1 regularizations, it adds a penalty proportional to the absolute value of coefficients, leading to feature selection by setting irrelevant coefficients to 0. Second, it is L2 regularization. Here adds a penalty proportional to the squared value of coefficients, preventing overfitting by shrinking coefficient towards 0 but not setting them to 0. Then we will see applications and case studies. So, logistic regression has diverse application across fields like first medical diagnosis, predicting the probability of a disease based on patient data, then fraud detection, identifying fraudulent transactions based on suspicious patterns. Then we have customer churn prediction, predicting customer churn based on their behavior and demographics. Then we have market research, predicting the likelihood of customer purchase based on their preference. So here we are done with our logistic regression, and hopefully you guys are able to understand the logistic regression. So thank you.